this is problem number 1 for assessment number 2. In this problem it says find the domain and range of the function. And they give you a function that's rational, and on the bottom we have a quadratic. So the first thing I want to do is I want to find the domain. And the domain's pretty easy to find because all I have to do for a rational is I have to take the domain and I have to say, all right, t squared minus 100. What are the values that t can't be? So t squared minus 100 not equals 0, meaning I know that the bottom can't be 0 because it's a fraction. Let's add the 100 over. We end up with t squared not equal to 100. Square root each side, and t cannot equal, when I square root this side and I square root this side, this will be plus and minus 10. So t cannot equal positive 10 and t cannot equal negative 10. So the domain of this function is going to go from negative infinity up to negative 10, but not including it. Then it's going to be going from negative 10 to 10. And then it's going to go from 10 to infinity. And this is how you exclude just negative 10 and 10. So that's the domain of the function. Now the range of the function it's going to be a little bit more tricky to figure out, I think. The first thing we can do is decide that we can figure out the horizontal asymptote. So horizontal asymptote is going to be y equals 0. And the reason it's y equals 0 is this is bottom heavy, right? So it's because it's bottom heavy, right? The power on the bottom is larger than the power on the top. We have a horizontal asymptote at y equals 0. Now that doesn't mean that our function can't equal 0, but that gives me kind of an idea that that might be a range value that we cannot get. What I like to do to find the range is I like to pick some number that's really small. So I'm going to say a function, I'll use g in this case. Well, I'll use f, just realize I'm talking about, I'll just change this to f of t. So I'm taking the function, I'm going to plug in, let's say, negative 10,000. I'm going to see what that number gives me. I'm also going to plug in a number that gets close to negative 10. So I'm going to plug in f of, and I'm going to approach it from the left side. So that's f of negative 10.00001. That's really close to negative 10, but it's coming from the left. Then I'll pick something that's close to negative 10, but coming from the right, so like negative 9.99999. And then do the same thing for 10 itself. So I'm going to do f of 9.99999 and f of 10.00001. And finally, I'll do f of 10,000 to cap it off, to check to see what do I get when I plug in 10,000. And I'm just checking to see what types of values am I getting when I plug in these different types of numbers that get close to our endpoints on our range. So grab your TID4. I'm going to store negative 10,000 as x. And then I'm going to type in the function. So I'm going to say fraction bar 7. On the bottom, I've got x squared minus 100. When I plug in negative 10,000, it gives me a really small number. I'm close to 0, right? Times 10 to the negative 8, that's close to 0. So I'm just going to say close to 0. While we're here, let's plug in the 10,000 as well. So we're going to say 10,000, store it as x. We'll take care of the really large and small numbers. Again, I'm going to get close to 0. And I'm close to 0, right, from the right side. So So I'm on the right side of 0 because I'm just above it. So that's implying that it could be 0 to infinity. Let's plug in negative 10.00001, store it as x, and then grab that function again. I get a pretty large number. I'm going to assume that if I were to plug in, and we can just test this real quick. Let's plug in a couple more zeros. Store it as x, and then grab that function. It should make that larger. As you can see, you're getting larger. So we're approaching positive infinity here. So we're going to just put a positive infinity sign. And then let's go ahead and store negative 9. I should have cleared that. So negative 9.9999. Store it as x. Oop, it's still there. That's good. Grab that function. Again, I'm getting a negative number, but it's a large negative number. Let's plug in negative 9.9999. We'll extend it out a little bit, store it as x, just to make sure that we're going toward negative. I'm assuming I'm going toward negative infinity, right? That didn't work out how I wanted it to. I think I put too many 9s in. Negative 9.999999. And then we're going to store that as x. There, that's better. There we go. So we're getting closer to negative infinity. Now let's plug in 9. That's close to the value of 10. So we're going to plug in 9.999999. Store it as x. And then we're going to grab that function again. That's negative infinity again. And let's plug in 10.00001, and let's store that as x. And grab that function one more time. And I get 35, so I'm going toward infinity here. Now, I need to double check here. We've got infinities, we've got negative infinities, we've got close to 0. But we never got close to 0 from the left side. Like, we got close to 0 from the right side for both these, but we never got anything close to 0 from the left side. So how can we do that? Let's look at this function here and let's see, how can we make this close to 0 negatively, essentially? Well, what if I squared some number that got me, let's say I use 0 here. If I use 0 here, what do I get? Well, let's try this. Let's do f of 0. So if I do f of 0 and plug that in, we'll slide this up a little. So 0, store it as x. And then I grab that function. It gives me negative 7 over 100. Now when I plug in 0, because I have a square function on the bottom, anytime I plug in a number that's both positive and negative, I essentially get the same number on the bottom. So if I plug in 1 now, let's store it as x. Or let's store like 5 as x. And then grab that function. So this gave me negative 7 over 100. And then I go ahead and grab f of 5, and it gives me negative 7 over 75, which is a larger number, right? Well, sorry, this is a smaller number. Now I do the same thing with negative 5. So if I plug in negative 5, I'm going to do negative 5. And I'm going to store it as x. And then I'm going to go ahead and grab this equation. I get negative 7 over 75 again. So if you notice that we kind of bottomed out right here. This value, right, these values here, they start to go towards negative infinity, right? And we saw that when we plugged in the negative 10,000, but we never plugged in 0. 0 actually is bottoming. It basically bottoms us out at the smallest possible number that we can get, closest to 0 from the left side. We know we can get close to 0 from the right side as close as we want, but from the left side we can only get as close to 0 as negative 7 over 100. So our range value then is going to go from negative infinity, because we saw that we got negative infinities. We saw that we bottomed out at negative 7 over 100. And we cannot get any closer to 0 than negative 7 over 100 from the left. But we can get close to 0 from the right, so we have 0. But you can never get 0 because obviously you have a fraction, so you're not going to be able to get 0 unless you have 0 on top. And then we go all the way up to infinity. So this is the range for this function. Now it's kind of difficult to figure out the range because you're not positive on the horizontal asymptote if the horizontal asymptote actually gives you the a missing range value, which it does in this case. But the hard part is finding the negative 7 over 100. But the one thing you got to remember is to always plug in, if you have a quadratic at the bottom, always plug in 0 because that's usually going to be a spot where you bottom out. And then obviously you plug in values close to your missing domain values to find whether or not you're getting close to 0, infinity, so on and so forth.